Hi, hello, and welcome you all to this video lecture. This is Dr. S. Selvabrinda, working as Associate Professor in the Department of Artificial Intelligence and Data Science from Ramco Institute of Technology, Rajpalayam. In this video lecture, we are going to dive into the topic of linear regression. So, before getting to know what is linear regression, let us see what is regression first. Regression is a type of supervised machine learning technique that is used to predict any continuous valued attribute. Regression is a statistical method that attempts to determine the strength and the character of the relationship between a dependent variable and one or more independent variables. So, the dependent variable can also be called as the target, and the independent variable can also be called as the predictors. Regression is used in various industries for business purpose, analyzing marketing behavior, trend analysis, and forecasting. So, next, let us see about the types of regression. So, there are five types of regression. First one is linear regression, next is logistic regression, then lasso regression, then rich regression, and finally polynomial regression. So, these are the five types of regression. So, out of which we are going to see about linear regression alone in this video lecture. So, what is linear regression? It is a type of regression that forms a linear relationship between the target variable and the independent variable using a straight line. So, here the target variable is nothing but y and the independent variable is nothing but x. So, the line separating the data points is the best fit line. So, the best fit line is represented by the equation y equal to mx plus c. Here, m is nothing but slope and c is nothing but intercept. Through this linear regression model, we can make predictions, uncover patterns, and gain deeper understanding of the data. Next is the types of linear regression. So there are two types of linear regression. One is simple linear regression, then multiple linear regression. So the simple linear regression has a single predictor and one dependent variable. And in multiple linear regression, there are multiple predictors and one dependent variable. So all these multiple predictors contribute in finding the values of y. So as I said in the previous slide, simple linear regression, there is one dependent and one independent variable. The model estimates the slope and intercept of the line of best fit, which represents the relationship among the variables. So here x is nothing but independent variable and y is nothing but dependent variable, and there are some data points indicated in blue color, and this data point is the observed value of y, and the straight line indicates the best fit line and is represented using y equal to beta naught plus beta 1 x. Here beta naught is the intercept and beta 1 is the slope. So slope is nothing but the change in dependent variable for each unit change in the independent variable. Slope quantifies the steepness of the line, whereas y-intercept defines the elevation of the line. So intercept represents the predicted value of y, when independent variable is 0. That is, when x is 0, what will be the predicted value of y? That indicates the intercept. So the goal of linear regression is to get the best values for beta naught and beta 1 to find the best fit line. The best fit line has the least error. So next is about random error or residuals. So random error or residuals is nothing but the vertical distance between the data point and the regression line. So in the previous figure, there is actual value and the predicted value, and the difference among them is considered as the random error. And next, the random error is calculated using the formula yi minus y predicted. So actual value minus predicted values. Mathematically, the best fit line is obtained by minimizing the residual sum of squares. So let us see what is residual sum of squares. It is nothing but the sum of square difference between the actual value of the dependent variable and the values predicted by the model. So the equation is given by RSS, that is residual sum of squares, equal to summation I equal to 1 to n yi minus f of xi the whole square. Here yi is considered as the actual value of the dependent variable and f of xi is considered as the values predicted by the model. And I varies from 1 to n. So it indicates the number of data points. And next is the cost function for linear regression. So the cost function helps to find out the optimal values for slope and intercept, which provides the best fit line for the data points. In linear regression, mean squared error cost function is used. So what is mean squared error? It is the average of the squared error acquired between y predicted and yi. So the equation is given by 1 divided by n summation I equal to 1 to n yi minus yi cap the whole square. So here n indicates the number of data points, yi indicates the observed values, yi cap indicates the predicted values. Next is about multiple linear regression. So it is a technique used to understand the relationship between single dependent variable and multiple independent variables. So the equation is given by y equal to beta naught plus beta 1 x1 plus beta 2 x2 plus and so on up to beta n xn plus epsilon. Here y is a dependent variable, beta naught is nothing but intercept, x1 x2 etc. up to xn is the multiple independent variables, and beta 1 beta 2 up to beta n is nothing but slope. Epsilon is considered as a random error. So this is the difference between simple and multiple linear regression. In simple linear regression, there will be one dependent and one independent variable, and in multiple linear regression, there will be one dependent variable and multiple independent variables. So next, let us see about assumptions of linear regression. So linear regression relies on several key assumptions to produce valid and reliable results. So these include linearity of residuals, then independence of residuals, then normal distribution of residuals, and finally equal variance of residuals. So these are the assumptions made by the linear regression. So first one, linearity of residuals. There should be a linear relationship between the dependent variable and the independent variables. And next assumption is independence of residuals. So the error term should be independent across the observations. There should be no correlation between the residual terms. So the absence of this phenomenon is known as the autocorrelation. Next is normal distribution of residuals. So the error terms should be approximately normally distributed. So the mean of residual should follow a normal distribution with a mean equal to 0 or close to 0. So here error terms normally distributed graph is given, and then error terms not normally distributed graph is given. So this normally distributed graph is done to check whether the selected line is actually the line of best fit or not. If the error terms are not normally distributed, this suggests that there are few unusual data points. And next is the equal variance of residuals. So the error terms must have constant variance across all the levels of independent variables, and this phenomenon is considered as the homoscedasticity. And then the presence of non-constant variance across all the levels of independent variables in the error terms is referred to as the heteroscedasticity. So the difference between homoscedasticity and heteroscedasticity is represented in this diagram. So homoscedasticity has constant variance and heteroscedasticity has non-constant variance. So next about key benefits of linear regression. So first one is easy implementation, next is interpretability, then scalability, and finally optimal for online settings. So that's all for today's video lecture. Thank you for watching. Do like, share, and subscribe. Thank you.